Hello, second grade. How are you today? I am so excited to be back with you because we are thinking about going back and putting into practice all that we've been learning about adding and subtracting numbers with 3 digits. Now, let's go ahead and look at our learning target, and then we're going to talk about what does that mean, okay? Let's go ahead and get those bows and arrows ready. I can solve addition and subtraction problems with 3-digit numbers. What does that mean? We solve addition and subtraction problems with 3 different numbers. Okay, so we're going to be adding 2 numbers together. We could be taking away. What is a 3-digit number? Yes, a 3-digit number is a number that has 3 digits. It has a digit in the what? The hundreds, the tens, and the ones place. So could my number 52 be a 3-digit number? No. What about 4,562? No, because that is a thousands, right? Our 3-digit numbers just have a hundreds, a tens, and a ones. And you're going to see that all the problems we do today, whether they're in a story or naked, we are going to be seeing 3-digit numbers, and we're either going to be adding them together or taking them away. Now, we spent a ton of time thinking about how to do this throughout the school year, right? We took a lot of time and we thought about how to add them or take them away using our base 10 blocks. Remember that? Drawing out our hundreds, drawing out our tens, drawing out our ones. What else have we used to help us add and subtract 3-digit numbers? Yes, a number line, an open number line. Not making every little tiny jump of 1, making those big jumps of your hundreds, your tens, and your ones. Yes, we also used, you guys are on it, we've also used our partial sums and our partial differences. And just thinking about how we can use equations to help us figure out how to solve these addition and subtraction problems. Well, why would it help us to be able to do all of these different ways? Why do we take all this time during the year to do that? It can help us double check it. One of my friends did that just the other day with some length problems. They showed it one way and got one answer and tried it out with a different strategy the next time. And they used their number line the first time, but then double checked it with their base 10, just to make sure that they were on the right track. What else might be helpful? Yeah, different problems sometimes are a little bit easier to solve with one strategy than the other. Sometimes it's easier to use a number line. Sometimes it's easier to use base 10, and sometimes it's just easier to write your equations, right? So you get to pick which strategy you like the best for that specific problem. There's lots of reasons why we take that time to think about all those different ways to solve. Well, today, we're going to continue putting that into practice. Now, I'm going to tell you that we are going to really zoom in on taking some time to think about how to use our base 10s to subtract today. So you can show it any way you want, but I'm going to really pull out our friends that are solving using base 10s. And it might not just be one way, right? We know that we can use addition to help us solve subtraction too. So we're going to take a closer look at that. I can't wait to see how you solve these problems. Let's read the first one and see if we can figure out what we're going to do first. Lexi bought 650 water balloons for field day. I can't wait for field day. She used 275 water balloons. How many water balloons does she have now? Let me read that one more time, and I want you all to tell me, what do we already know? Lexi purchased 650 water balloons for field day. She used 275 water balloons. How many water balloons does she have now? What's something we already know by reading the story? Yeah, she bought or purchased 650 water balloons. Now I'm going to underline that word purchase because that means she got them, right? That's how many she had. What else happened? Yes, she used 275 of those water balloons, didn't she? And if she used them, what does that mean? Does she still have them? Did she get more? Did she give some away? What does that mean? she gave them away, right? Or she does not have them anymore. She had 650 and now she has 275 less balloons because she used them. They're probably popped all over the field. What are we trying to find out? How many water balloons does she have now? I want you to take just about 30 seconds to write an equation with an unknown to match this story. What equation can you write? What number are you starting with? Why? Are you adding or subtracting to match this story? Subtracting to match it, aren't you? Okay, and what are you taking away? All right, friends, let's come together really quick. What equation can we write to match this story? 650. Why are we starting with 650? Because that's how much she bought, right? She bought those or purchased those. Then what are we going to do? Why are we putting a subtraction symbol? Because she used them. And how many did she use, everybody? 275. All right, and then what do we know? Oh, I'm going to write used. Yes, we got to label that equation. Okay, then what? I'm going to put an equal sign. What are we going to put after that equal sign? And what does that box represent? How many she has now? Right? How many she has after she uses 275 of them. Now, second grade, I know that we can solve this in lots of different ways. Lots of different strategies can help us get to that unknown. I want you to think about what is going to be the best way for you. What's going to be the most efficient? What's going to help you solve it quickly? And what's going to help you solve it accurately to help you find the correct answer. Take a few moments, and I want you to honor that private think time we want to be giving our friends each and every day to think through this work. And as I pop around, I'm going to be asking you different questions so I can learn more about your thinking, what's going on in your head, because I can't be in there with you. Go ahead and begin working. What are you drawing first? Okay, so when you're using your base 10, you're drawing 650. Where are you, how many hundreds are you drawing? And how many tens? How about your ones? You are not subtracting, but the symbol says subtracting. What are you doing instead? Where are you starting if you're adding? Okay, so are you adding 650? Adding to get to that. Okay, so what are you going to do first to get to 650? Starting with your ones. Ooh, I see that number line. That's really helpful, isn't it? Where are you starting on your number line? Are you jumping forwards or backwards? Where are the balloons that she bought in your model? Where are the ones that she used up or probably popped? And then what does this number represent? Okay. Why did you decompose that number? Okay. All right, friends, coming together in 5, 4. If you're not done and you're at home and you can pause me, you're welcome to pause me until you're ready to jump back into our learning. 3, 2, 1, and pencils down, done. Got lots of friends doing some great work. Can I have you tell me what you did with your base 10s? Why did you draw 650? And how did you draw 650? And what do each of these squares represent? They each represent 100, okay? I'm seeing some wiggle waggles out of the corner of my eye. You guys already know that, right? This is a review, isn't it? Then what are you going to do? What do each of those sticks represent? 10. So this shows 650 because 600, 610, 620, 630, 640, 650. How many ones are you going to draw? Why not? There is a 0. There's our hundreds, our tens, and there's a 0 in that ones place. Okay, so what are you going to do next? Okay, so for those of you who maybe did not hear my friend, they said, well, I wanted to take away 5 ones, but there weren't ones. So I had to break up a 10. So I crossed off a 10, and what did you do once you crossed off a 10, what did you do? Okay, you traded it for 10 ones because 10 ones and 1 10 are the same, right? Okay, then what did you do? Okay, you crossed off your 5. 1, 2, 3, 4, 5. Check. What did you do next? Oh, you had to cross off 100. Why did you cross off 100? Because you want to take away 7 tens, and how many tens did you have? Oh yeah, you only had 4. So am I going to draw just 7 tens? No, I'm going to draw what? 10 tens. You guys are on it. And why 10 tens? Because 10 tens is the same as 100. We have to trade it. It has to be equal, right? 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. If we cross off 100, we have to trade it for 100. All right, then what did you do? Crossed off 7 tens, okay? 1, 2, 3, 4, 5, 6, 7. But that's actually 8 crossed off. Oh, this one went over here. Okay, so you crossed off your 5 ones. You crossed off your 7 tens. 1, 2, 3, 4, 5, 6, 7. Okay, and then what did you do? Went over to your hundreds, and how many did you cross off? 2, right? Because this 100 went to those right there, and then you had to cross off 2 more. So what did you find after you did all of that work? You have 300, 10, 20. You're going to circle what's left over. Here, I'll circle my hundreds too. 5, 6, 7, and that's 7 tens, which is 70, and then what? You had 5 left. So what is your difference, the answer to the subtraction problem? What is that difference? 375. If you agree, wiggle, waggle. Okay. You also used your base tens, but you did not subtract. What did you do? If you didn't subtract, what did you do? Because there's a subtraction symbol right here. Where did you start? You start with 652? Oh, what did you start with? Oh, okay, so you start with 275. 10, 20, 30, 40, 50, 60, 70, and then 5. Okay, and so are you adding 650? What are you doing? You're adding to get to 650. So we start this friend, we'll go back to that a little bit. I'm getting a little ahead of myself. Okay, what did you do? Tell me about it. Tell us about it. All right, so you're trying to get to 650. Can I write that down here? Did you do that? Help you remember? Okay. What did you do first? You had to get to 0 ones, but you already have 5 ones. So how do you get to 0 ones if you already have 5? Oh, okay, so if you add 5, then you have 10. Okay, so you added 5 ones, but then you made it go over here to make that extra 10. Okay, because that is 10. So now you have 0. If you take all these and you move them over here. Okay, and then what did you do? All right, so you have 8 tens, but you only want 5 tens. How do you do that? That's 80. Okay, so then how many tens is going to help you get, how many, what are you trying to make here? 15 tens? Why 15 tens? Okay, because if you have 15 tens, 10 of those tens can go over here to the hundreds. Okay. All right, so this is how much? 80, all right. 90, 100. Okay, and you took that and put it over here. Okay, that made it a little bit easier. That's 100, all right. And then 110, 120, 130, 140, 150. So now there's your 5 tens. I gotcha. That's very smart. Very smart. Does anybody else see this? I'm seeing some looks of, that's interesting. I do like how you circled that 10 and put it over, that 100 and put it over here so you could see that 5 left over. That's a smart move. So then how many tens did you add? You added 5 ones right here, right? How many tens did you add to get to 5 tens left over? You added 7 tens or 70. There's your 5 extra, and it took 2 to get to that 100. Okay. Then what did you do? You saw that there were 3 hundreds, and then what did you have to, you're trying to get to 6. So 1, 4, 5, 6. So now you have 6 hundreds, you have 5 ones, and you have 5 tens, and you have 0 ones. So how many hundreds did you have to add? You added 5 ones, you added 7 tens, and you added 3 hundreds. Oh, I'm going to circle it with another color so you might be able to see it a little bit easier. There's your hundreds, your tens, and your ones. And what did you notice? So what do you have 370 and 5. Where else do you see 375? Right there. But what equation would you write to match this work? Because it's not the same as this one. This friend, sorry, was 650. They took 275 away, and they had 375 left, but that's not what you did. What did you do? Started with 275. We're trying to add something to get to 650. Gotcha. And so what did you add to get to 650? 375. Does everybody see that? How are these two ways similar, and how are they different? Well, they both got, that's 375 is the answer. What else do you notice? They both use base 10. Absolutely. They both drew out their hundreds, their tens, and their ones. What else did you notice? Okay, so one added and one subtracted. But the numbers were in a different order. Can we add and subtract to solve the subtraction problems? Can we use both addition and subtraction? We can, right? But our unknown is not going to be in the same place. We're going to use the same knowledge to help us solve our first stop and practice. So notice this is a problem with a word problem, a story. Sometimes I like a story because it helps me make connections about what's happening. Like I can see the actions in the problem. We can't see an action necessarily as easily with our naked problems, but our naked problems give us a little less to have to think about, right? So let's take a peek at our first one. These are our stop and practice, and our lessons tomorrow, we're going to do the same thing. We're going to stop and we're going to practice because we want to make sure that we get time putting this idea of adding and subtracting just with a naked problem makes it easier. It makes us a little bit more confident in how we're solving this. So our next problem, you can read it, 423 minus 361. I want to give you guys time to solve, and I'm going to be asking you the same questions. So I'm going to say those questions to you now, and then I want you to pause and work, and then we'll come together and show this. So I want you to be telling me where is your 423? Okay. Where is the 361 that you're taking away? If you're adding to help you find the answer to that subtraction problem, what does your equation look like? What are you doing first? And how are you going to get to that total, or that sum? Okay, so this was the sum, 650, right? The difference was 375 because we were starting at 275. We can subtract to find that, or we can add to find that difference. But the difference is unknown both times. Okay, it's one of those parts that's unknown. Same thing here. We're missing a what? We're missing a part. We're not missing a whole. We know that whole. What's going to come here? Go ahead and begin solving, and we're going to come back. Pause me, and then we'll start showing our thinking. All right. So many of you have had some good, strong thinking time, and I've seen number lines. I've seen partial sums. I've seen partial differences. Okay, I've seen people working and using some of these different strategies to help them make sense of this learning. And our numbers are a little different this time. Let's start with our subtraction again, and then we'll show that addition, because I saw some friends using that addition to help them find that unknown as well. Let's go ahead. Talk to me over here. What did you do first when you were subtracting using your base 10? All right, so you started with your 400, then what? 20 and 3. Okay, and then what did you do? Oh, you just took away one of those ones. Then what did you do? You had to take away 6 tens, and what did you find? Yeah, you didn't have enough. So we're crossed off one of those hundreds, and where are you going to put? What are you going to put in its place? 10 tens, okay. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Trade 100 for 100. Okay, and then you took away those 6 tens. That's 2, 3, 4, 5, and 6. Okay? And then what did you do next? Took away 3 hundreds, right? Because here's your hundreds, your tens, and your ones. And what did you find out? You had 60, 6 tens, and 2 ones left over. What did that leave you with? 62. So what's going to go right here? 62. I'm seeing some wiggle waggles. Lots of friends got that same answer. Okay. Did you all solve it using that same strategy? Some did, some did not. All right, what about our adding? You got brave and did the adding this time around, didn't you? That was very courageous of you, trying out something new. So where did you start when you were adding? Okay, so you started with 361, okay? And you said you added. What did you add to 361? Okay, you put a box for that unknown because, okay, you're trying to get to 423. Gotcha. So what did that look like in your work? 300, 3, 4, 5, 6, 60. All right, and 1. Okay, and you put a line down here and wrote 400 plus 20 plus 3. And why did you do that? That was a smart move. So you knew what you were trying to get to. Okay, so it's kind of like your equal sign there at the bottom. So what did you do first? Okay, so you added 2 ones. That was a pretty easy thing, wasn't it? Okay, 1 1 plus 2 ones equals 3 ones. Okay, so plus 2. And then what did you do? You already have 6 tens, and you're trying to get to only 2 tens. So what did that tell you? Got to make 100 so you can, okay. All right, so then what did that look like? 10, okay, so you start with 60, gotcha, 60, 70, 80, 90, 100. Okay, you did the same thing that the other friend did. Okay, 100, draw it over here. Okay, it's 100, 110, 120. Okay. That gave you 400, so you didn't have to do that. And what did you notice about this? Once you took that 100 away and drew those extras, you only had 2 10s left, so that's 20. So what did you add? How many 10s did you add altogether? We know we added 2 1s. Your 10s are down here. So that's 10, 20, 30, 40, 50, 60. So how much did you add to 361 to get you to 423? 62. Did everybody see that? We can use addition to help us solve subtraction. We did that with the easy numbers earlier in the year. And now we know we can do it with these 3-digit numbers. Friends, we're not going to leave this idea. I'm going to give you a chance to do this addition one on your own. Show me your thinking. Show me how you're using. You can use any strategy, but if you want to go back to that base 10, you're welcome to. And then tomorrow when we come together, we're going to be using our number line to see how we can add and subtract to solve those subtraction sentences. Great work today. Love seeing that thinking, and I love you talking about your numbers and what they represent from the story or where they are in that naked equation. Have a fantastic day, second grade. Keep working hard.